morning, everyone. So many people, so nice to see you. Yeah, I thought that nobody would come at 9 a.m. Friday morning after all the parties. You must be really fond of software testing, I believe. Does anyone of you never heard about test containers or don't know what it is? No one? Oh, some people. Okay, then, okay. I'm not in vain here still. So my name is Ivan. I'm a staff software engineer at the company called Synthesized, and we are doing software which facilitates testing, data mocking, and stuff. Also, I teach Java and Kotlin at a number of universities. And what's important here, also, I'm a big fan of test containers technology. I've been using it since 2016, actually, and I contributed to this open source project. I'm not affiliated with Atomic Jar or Docker in any way, so here you have a chance to, to hear an unbiased view, unbiased opinion. Why I decided to make this presentation? As I told you, I'm a user enthusiast of test containers, really. However, quite often, I argue with my fellow engineers who consider test containers to be the ultimate solution for every problem in integration testing. And so I would like to share here some insights based on my personal experience in integration testing in Java and Kotlin. However, I believe that the takeaways of this talk must be useful for everyone, for every language, as test container is available in many languages, and test mocks, they are available in many languages. So the test takeaways must be general ones. Okay, what's the modern integration test? How modern integration test looks like? So we have a system under test, but it cannot work on its own, right? First of all, we need a relational database connected to it. Then, if we are using asynchronous communication, then we need a message broker. Then, if we are using microservice architecture, we have some peer services. We might want to communicate with some external service, maybe some banking, maybe some payment system or some government system passing XMLs through. And cloud stuff. Maybe some cloud-based cache, maybe some cloud-based database. All this environment is needed for the system under test. How do we do? How do we provide this environment? Well, two alternatives, mocks and real systems, right? Some years ago, I found this video somewhere on Twitter. Mocking is like teaching chemistry with software emulation. So as we see here, teacher virtually puts something in a test tube and test tube explodes. Well, at least it's simulated explosion. What's the advantages? It's convenient for the teacher. What's the disadvantages? I think it's not very convincing, right? Because only real experiment can convince us, we can explore real features of chemical reactions. What do we have in software testing for real experiments? Test containers. Well, I'm not going to repeat people who made amazing talks yesterday and day before yesterday about test containers. So it's an open source library which provides lightweight testing instances of anything that can run in Docker container. And as you can see, it can work with any language, with any programming language. And this is the classical example of using test containers. If you need Redis, for example, and you know that this Redis image it can be run in Docker, so you just create a new generic container, just like you create a hash map, for example, or array list. And then, but under the hood, it spins up a real Docker image and spins up a Docker container. And you get host, you get port, and now your Redis connection is ready to be made, and you are ready to test, to write integration test with real Redis, which is cool. And it's so cool, and it's a real game changer, actually. And it's so cool that well, in recent years, I had to communicate with folks who had a set of stereotypes. Like mocks, they are unreliable. Yes, they are. We are going to discuss this. So we can run everything in test containers and test it, and forget about mocks, and forget about H2 database. Who used to use H2 database for testing? Oh, lots of you. Cool. So some people believe that this this approach is outdated, so it's superseded by test containers. In a way, it is, but in other ways, there are still scenarios where you might want to use it. We'll address all these opinions later, but first, let's consider the case of external service. So, well, here, I think the common opinion is that this is the main use case of integration mocks or generic mocks. So in Java, it's wire mock. In Python world, it's mountebank. We also have lots of other libraries and services that can mock external business services, business solutions like banking applications, like payment systems, like government systems. So everything that's beyond us. And well, I like this example from the book called Humans versus Computers. The example on importance of testing, of proper testing of corner cases of external systems. So somewhere in some country, it was decided to release from prisons everyone who has not committed serious crimes, like murders. And of course, there was some government-supported database and external system, and you have REST client for it, and you can load murders committed by somebody. And this is the code used for it. Do you see the problem here? So when it's OK, when external service is up and running, then we really get a list of crimes, right? It can be an empty list. But when something wrong happens, some network glitch, we have exception. OK, we log it, fair enough. And then by default, we return an empty list, which can be interpreted by your business logic like this person haven't committed any murders. We can release them from prison. So this is the real example of an importance of testing corner cases of external systems. And for this, systems like WireMock, they provide all the functionality. So as all of you know, we can program a response in some request. But moreover, WireMock and all the other mocks I'm going to talk about later, they are able to record and verify calls to external service from our system. So we can verify our system, what methods were called, what commands. And also mocks, well, WireMock in particular, it can work as a spy or a test proxy. So it's not necessary to, maybe in some situation, it's not necessary and it's not possible to emulate the real system, but still we can intercept the request, we can record and verify the request, so we can write some tests, some verifications. Then we can delegate this request to external system and get the response. So modern integration mocks, such as WireMock, they are capable of doing this. OK, what about these guys? Databases, Redis, Kafka, RabbitMQ, Cassandra, and stuff. So what are we doing about them? So this is, of course, this is a sweet spot for test containers, right? So they are too complicated to mock. And test containers here is a real game changer. It makes so much better the testing of these things. So first, let's consider it from compatibility point of view, right? So mocks, if I'm going to write a mock for some database, for Redis, for example, there is no guarantee that this mock will replicate the behavior of the real system, right? Moreover, if I'm going to try hard, still writing a mock means writing a bug-to-bug compatible re-implementation of the system. Look, no sense person is going to do this, right? So this is just impossible. While test containers, they are the real system itself. So it's a clear win for test containers in this scenario. Okay, cool. But there are other aspects of testing. What about ease of use and startup speed? And here we have quite the opposite. So mocks, they are just regular dependency. They are just, in most cases, they're just a library that you pull into your project and run in the same process with your test. So your tests are running quite fast with mocks. While in test containers, well, you start test containers test for the first time, you download, you're doing git pull, and then you're running, and then you are stuck with this. What's this? First of all, test containers require Docker to run. Well, nowadays in 2024, what software developer are you if you don't have Docker on your machine? I think everybody has Docker nowadays. So, okay. Then you need to download the image. And images, they can take hundreds of megabytes, as we know. And so now it all depends on the size and internet speed. Then you say, OK, I downloaded the image. It is cached on my machine. Now it's going to be fast. No. Now, each time you run the test, the image needs to start. And it all depends on the images, actually. This is the real screenshot from Allure test report of our real production tests. It's a bit outdated, not a bit, it's quite outdated, maybe a couple of years old. Things got better, but it illustrates that, for example, MS SQL container takes 40 seconds just to start. So you are the software developer, you need to run the test, you click the run button, and then you wait for the whole minute just for these tests to start. And that's the problem. Okay, container image providers, they're also doing everything to speed up the startup time. For PostgreSQL, for years, PostgreSQL starts immediately. Yesterday, we heard another nice talk about testing of data applications, and they showed us that currently the most modern Oracle image starts in 10 seconds, which is nice. Okay, it's great because it's used to start in maybe in 1 minute, but still, it's whole 10 seconds. In 10 seconds, your normal unit test is going to start and run and finish, and you already got the feedback if it's failed, if it's green, right? So still, it's really, really slow. And the worst situation for test containers from practical point of view is the situation when, for example, I have a laptop with ARM-based CPU and Docker image is not compatible. Then there is no way for me to run Docker image on my machine. For this, we have a nice workaround, which is Testcontainers Cloud. Testcontainers Cloud is a cloud solution. So you install on your machine a lightweight client, and you connect to Testcontainers Cloud. And everything, all your test containers are being run in the cloud. No problems with ARM processors, no problems with memory. As, for example, MS SQL container, it takes up 8 gigabytes of memory minimum immediately. So if your development laptop does not have like 32 gigabytes, you cannot test your you cannot run your test containers-based tests for Microsoft SQL Server, unfortunately. So all these problems they are overcame with Testcontainers Cloud, but this is paid service, and it requires internet connection. So if you, like me, like to work, like to debug stuff while commuting on a train, you cannot do this because you need a stable internet connection still for this. These are disadvantages, difficulties, like practical point of view for test containers. So from the point of view of convenience, so mocks, they are fast and reliable, and because they are fast and reliable, it makes people run them more often and write more of the tests, of the mock-based tests. And yes, mocks, they are not working like the same, precisely the same as real systems, but Still, if your software developers, they like to write these tests and they like write a lot of these tests, maybe it's better. While heavy tests are too time consuming and software developers, they sometimes tend to skip their execution, or this is like heavy test, let it run on CI, I'm not going to change it, I'm not going to touch it. Maybe I will just introduce this small feature and I'm not going to write another test containers based test. This is, all from my practice. What else can we talk about, like integration mocks versus test containers? Integration mocks, they provide white box testing. So integration mocks are libraries designed specifically for testing. So they provide like all the facilities. So you can verify the calls from the system under test. How do you verify what like you are running with your database, real database in the test containers? How do you verify what queries have been sent? It's a tricky. You can do it, but actually it's a tricky task. While if you have a good integration mocks, you can do it straight away from the box, and you can simulate any state, including failure, and facilitate corner cases. While for test containers, it's challenging to set up in the system in the desired state. For example, you are testing your system with Redis, and you want to test the situation where Redis is not available, when it crashed, when it disappeared from the network, and then reappears again. And how do you do this with real Redis? Because Redis is a reliable system, right? It's normally not crashing. So, and with mocks, mocks, they are designed just for that, just for testing of corner cases. So if you have a good mock, you should not neglect it and say, oh, I have test containers, I can test everything there. No, you cannot. And another story is synchronous versus asynchronous execution, but more on that later. And finally, availability. Well, it's good if you have a reliable, a good integration mock for your system. There are a number of mocks for Redis, for Kafka. I'm going to demonstrate them later. But if they are not available, then you have to write it on your own or use test containers. With test containers, of course, the good thing about test containers is that they can be used for anything that can be run in containers straight away. OK, so that was just preliminary considerations. And now I'm going to tell you like 3 stories from my practice. And I'm going to mention some specific technologies like Redis or Kafka or Apache Beam. Most probably you are not working with them. Maybe you are working with them. But this story is not about these systems. This is about testing approaches. So I would like to focus on approaches to testing. So Redis. Redis is quite well-known system, right? So if you Google for GitHub repositories for mocks of Redis in various programming languages, you will find a number of them. They are like moderately popular and quite popular given that they are so specific. This is very specific software. And all of them, they are being actively developed and maintained. So I mean, the mere fact of that we have this software means that there is like a demand for Redis mocks, despite the fact that we have a nice option with test containers. So what's the problem, or why do we need to have this? Well, I want to tell you about JDis mock, just because I'm the main maintainer. Like for recent years, I've been the main maintainer of JDis mock library together with my students. So they are doing development and bug fixing of JDis mock as their semester work. So as of currently, yeah, free workforce. Yeah, they've got marks for that. But yeah, as of currently, we support approximately 64% of the Redis commons. But 64 of most popular Redis commands, I would say. So if in recent years it used to be lots of requests, so please support this command or that command, now they are quite rare because I believe that we supported all the Redis commands which are practically usable. And how do we make sure that Redis mocks works the same way as the real thing, the real Redis? Of course, we are using test containers for this, and we are using an approach called comparison tests. So actually, every test scenario is being called twice. First against the mock, and then against the real system running in test containers. So you see, we are using test containers in order to spare users of our library from using test containers. This makes our test very reliable, right? So if we have green tick for mock, but red cross for real thing, this means that our test is incorrect. We need to fix assertions, actually. So we compare it against the real things. And another approach that we are using, since Redis is open source, or it used to be open source until recent times. Now it's not, unfortunately. But since Redis used to be open source, we can take its own tests written in a language called TCL/TK. Who knows about TCL/TK? Wow, quite a lot of people. Yeah, so there are thousands of tests, and we're constantly making like more and more of them green. And so this led to like the situation where we like quite near to the behavior of real Redis. So why mock if we have test containers, right? So compare this and this. It looks very similar. So here you create a new object and you get host and port. And here you create a new object and get hosted port. The main difference is that now Redis mock runs in the same process as our tests. It doesn't require Docker, and it's just a regular Maven dependency. So you pull, like in your build Gradle file, you pull this dependency into your project, and you are happy. It starts straight away, and it works faster, and it's less demanding to like. It just cannot be compared with test containers, like when it comes to memory consumption and resources consumption. So you can write lots of tests here, but not only this. Redis mock is designed specifically to be a library which facilitates testing. So we have an interceptor, and you can intercept the commands sent, and you can explicitly specify the response. For example, if you don't want to set up your Redis database with data, and you just wanted to send a specific response for a specific request, you can do it, just like with any other mock. Or you can delegate to the mock, which will emulate the real thing. Or you can check the request, so you can write your assertions in the interceptor and verify that indeed the system under test sends these and these commands to Redis. You can simulate failure, so you can break connection, you can restore connection, and check how your system is going to behave there. This is not possible with real thing. And if you like, you can use Redis mock as a test proxy. So you can delegate to real thing if you still want to run it in container and send response. But you still can intercept, you can verify calls, you can send something hard-coded as a response to your request. So all this is possible. So conclusions on testing of Redis. For most Redis testing tasks, test containers is still game changer. So if you are just starting with Redis and you are starting with testing Redis, my suggestion for you, the first option is still test containers. For 90% of testing tasks, test containers works, and it works better than any mock. But if you want to verify some specific corner cases, if you want to study it in situation when Redis itself fails, then Redis mock is helpful, or any other mock of Redis, because it's not the only library which mocks Redis. There are a number of them. And of course, with Redis mock tests, you can run them like faster and without Docker and without memory consumption. Another story is about Kafka and Kafka Streams. And actually, I have, well, in co-authorship with John Rossler, who is who's working in Confluent, or used to work in Confluent, and currently, and he contributed to Kafka Streams framework a lot. And together we made this presentation and a blog post and Confluent blog about Kafka Streams testing. And the main idea is the following. So in Kafka world, we also have two possibilities. We can spin up the Kafka cluster in test containers, of course, and test it against containers. And we have a specific thing built into Kafka Streams framework. This thing is called topology test driver. So this is a specific test mock for Kafka Streams. And what are like advantages of topology test driver? You already know them. They all are advantages of a good test mock. So it's simple, it's just a regular Maven dependency. It doesn't require you to run Docker. It doesn't require you to spin up real Kafka cluster. It's fast and it's convenient. It's convenient because it has an API targeted for your tests. So you have good API for data arrangement. You have like nice API for assertions of the result. So it's testing tool. The topology test driver is a testing tool actually. But the main difference is that unlike real Kafka, which works asynchronously, topology test driver is specifically made as a single-threaded synchronous application. And that makes huge difference and principal difference, a game changer. So let's talk about asynchronous tests and asynchronous testing. Because some systems that we test, they are asynchronous. We can monitor their state. We can observe their state. But we cannot, if the system does nothing, we cannot understand if it's stalled or if it's doing something useful or something else happened. Web browsers work this way. So all the browser automation tests, they are synchronous tests. And Kafka tests, the tests against real Kafka cluster, they are also asynchronous. So let's make this thought experiment. The contract is, we send ping to the system, and we expect to return it a single response pong. So if there is no response, then it's a bug. If there are 2 responses, 3 responses, then it's a bug. The response must be a single one. So we send ping, 2 seconds passed, no response. Should we fail a test or should we wait? We don't know. 3 seconds passed, no response. On the 4th second, we got the response, the expected response, bong. Okay, are we done? Not yet, because we're expecting a single response, right? So we need to wait for some more. 5 seconds, silence. 6 seconds, silence. Is the test green? Maybe it is, maybe not. On the 7th second, we got another response, and the test must be red. So as you can see from this thought experiment, the fact that, well, the color of our test, will it be green or will it be red? It depends on the times of the timeouts set for the test, right? So like here, this is an example of Kafka test. We have a duration of polling duration, for example, 5 seconds. Arbitrary set, just timeout. So we are hopeful that in 5 seconds we will get the correct result. So we will be able to decide that this is what we expect to be. But why 5? Maybe 6, maybe 4. And this leads to the problem of flakiness of our tests. So all the asynchronous tests, they're inherently flaky, and you cannot do anything about it. You just cannot do anything about it. So a fundamental problem of every asynchronous test is we don't know if it is the final result or have we not waited long enough. Well, in order to partially fix this problem, we have a utility library. Who knows about a utility library? Oh, quite many people. Okay, then I will quickly skip about. The awaitility just checks in rapid succession. It calls this lambda, and if say for 10 seconds, each 100 milliseconds, it will call this lambda, and it checks if it returns true or false. So if it returns true in less than 10 seconds, in less than the set waiting time, maybe in the first second, if it returns true in the first second, then the test is green. So we save quite a lot of time for waiting with awaitility. If 10 seconds passed and it's still false, then test is red. And we have lots of other capabilities. So we can set various conditions. We can have exponentially growing polling interval. And awaitility helps us a lot. And by the way, a couple of days ago, the talk about test containers, they shown us the integration test with Kafka and test containers, and they used awaitility there. And but the fundamental problem here is that awaitility speeds up asynchronous test, but it doesn't overcome the fundamental problem of asynchronous tests. The fundamental problem is we have to set up these waiting times, and they are quite arbitrary, and there is no guarantee. In browser automation, as I mentioned, frameworks such as Selenide or Playwright, they provide implicit waits for conditions to be met. So it's the same actually in browser automations. Awaitility is a nice library, but I have to mention another problem with it. We are entering the slippery path of concurrent Java programming. So if we really want to write a reliable code with awaitility, we need to write a multi-threaded, highly concurrent Java code. For this, you need a senior Java developer, not your junior, not your tester, but senior Java developer who can at least verify this code. I'm not going to go into details here, but Java specialists, they must understand. So we need to take into account cooperative termination. We need to use thread-safe data structures, and we should not forget to finalize the execution. So all this is needed, all this boilerplate code is needed just to use awaitility correctly in the context of multi-threaded execution. So you need, literally, you need a senior engineer to set up this asynchronous test. While with topology test driver, this is how your test looks like. So output topic here is a variable, is just a mock of the topic in Kafka. Read values to list means synchronous reading of all the values left in the system after all the processing. So you are guaranteed to get the final result synchronously. So if it's A and B, then it is A and B. There will be no C left or D left in the end. So, and it's just a couple of lines of code because it's single-threaded. And you don't need, and I remind you, you don't need Docker for this. You don't need like any Kafka cluster for this. It's just a Maven dependency. So this is why if you are developing Kafka Streams applications, you must use topology test driver. Otherwise, you just cannot reliably test your business logic, your transformations. And I believe the same is true for other streaming frameworks. I believe Apache Flink has something similar, some specific mocks for this. And you should use them because they are designed specifically for testing. But what's the pitfall? The pitfall is that the synchronous nature and the lack of caching and single thread, all this stuff leads to differences in behavior. And it's possible, it's very easy to construct very simple code examples that are green in your topology test driver tests, but that they won't work correctly on a real cluster. And once again, if you are about Kafka, if you are interested in Kafka testing, I recommend you this Confluent blog post by me and John Rossler. So you need to have a specific knowledge about the limitations of the topology test driver, what it can and what it cannot do in order to use it. So in the end, although topology test driver remains essential despite its limitation, you need to understand that it cannot fully mimic the behavior of Kafka cluster, and you need to understand these limitations, and you need to conduct a limited number of tests in containerized Kafka cluster when necessary to check the corner cases which cannot be surfaced by topology test driver in Kafka. And what are these corner cases? Well, it's a separate story. You need to dig into this technology to understand it. Okay, third and final story. Mock is one of the supported backends. So there is quite a big number of frameworks and applications which work like this. And it may be even your code in your organization. So you provide some abstraction level, some API, and this API can work with a number of backends, maybe a number of databases or some other backends which are interchangeable. And in this case, you can implement as one of the interchangeable backends a mock backend. For example, Apache Beam, it's a unified programming model for ETL, batch, and stream processing. And it supports, so it provides a unified API, so you can combine all these pipelines, data processing pipelines, and it has a number of runners: Flink, Nebo, Zamza, Spark, and so on and so forth. And besides that, it provides a direct runner. And direct runner is a dedicated test mock for this. So you are not supposed to run your real life data transformation on direct runner, but you are using your direct runner to write tests. The problem here is the following. So all these huge big data systems, they have sets of capabilities, of features. And somewhere these sets intersect, of course. Every such system has map method, has reduce method. Yeah, it's basics. But of course, they have some specific features and capabilities. So in Apache Beam, they keeping these huge sheets of capabilities, what's supported, what's not supported by this and that backend. And the problem with direct runner is that it's like a superset, like the union of all the sets. So you can run the test on direct runner, and then you will find out then on some real life backend it won't work, just because the real life backend just does not support the capability that you used in direct runner. So failure on direct runner means the code is bad, nonetheless. So it still makes some sense to write tests in direct runner and execute them because they are fast. But successful execution doesn't mean the code is good. So there are some things like Google Cloud Dataflow, which simply does not provide any containers, and you need to test with real things there. On the other hand, there is some not very well known, some opinionated framework called Celesta, and let me skip it. It's dedicated for fast, rapid application development that rely on relational databases. So it supports actually 5 databases. And it provides the unified model, the unified API for 5 of them. And one of these databases is H2. So please note this fact. Unlike another example of this system, so this mock backend, right, test backend, Celesta works on the intersection of all the sets of the capabilities of all the backends. So every database has tables, views, columns, indexes, a set of basic types like varchar, integer, and so on and so forth. And so we have a unified API, type-safe API. We have Celeste SQL, which is transpiled into specific dialects. And only a subset of features is supported. So this is the price that we pay. If we are using such a framework, unlike the previous example, we are limited, we are confined in a subset of all the features. We cannot use some specific feature of Oracle database or MS SQL database because they are not supported by our unified interface. How do we achieve the fact that these features are working the same way for every database supported? Again, we are using comparison tests, and they are using test containers for this. And again, we have a situation where library or framework developers are using test containers in order to spare the developers of business logic from using test containers and write faster tests. So here, every test, unlike in JDSmoke, which for JDSmoke we have 2 executions of each test. Here we have 5 executions of each test. And thus, well, Celeste developers, they verify the fact that it works the same for every backend, including H2. H2 does not run in containers. We don't need test containers to run H2, as it's in memory database. And this means that if our code written works on H2, we are guaranteed, or we promise to guarantee the fact that it will work on PostgreSQL, MS SQL, whatever, because we tested it on the features that we provide via our abstraction level. This means that we can use H2 database as a mock backend. Well, H2 is an in-memory database. It does not require test containers. It starts in the same process with your test. It migrates instantly. Queries to H2 are easily traced. You just modify JDBC connection string, and you have all the queries in your logs, unlike, well, tracing in Oracle or some other databases might be quite tricky. And after the test, the state is forgotten because it's in memory. So the next test will be running from just from scratch. By the way, if you want to trace SQL queries, you might want to use something like log JDBC driver, which actually works as a proxy. So there are some workarounds for tracing of SQL queries, but still, if you can do it with H2, you can do it much simpler. For example, if, well, here, Celeste test is just an extension for JUnit 5. In every test, we can provide a call context variable, and this call context provides us with a connection to H2 database already prepared, already migrated for you, and you also have type-safe API to interact with this database. So you are writing your integration tests just in a way you write any unit test. When you create a hash map and test some algorithm against the hash map, you're just putting some data, 2 or 3 records into it, and you just call the methods, you just verify the result of the methods. So actually we had, yesterday in the evening, we had a nice talk about modern approaches to testing of software which talks to database. And things are getting better and better over recent years. So, but still, the Bay unit is inconvenient, in my opinion. And still, this problem is not solved, is not fully solved. While you can solve it using writing your frameworks like this, or using these frameworks in this way. So when you limit interaction with database by some abstraction level, when you make sure that your, let me show this slide with comparison tests again, by making sure that your abstraction is going to work the same way with all the supported backends, then you can use H2 as safely use H2 as a backend, and write fast and reliable tests. So, but this comes at a price, and the price we pay, of course, is the limitation of functionality. So we cannot write very specific queries, the ones that we love to write, right, as software engineers. So, oh, we are using Postgres database, let's utilize some specific functionality which we have in Postgres database only and not in all the other databases. So in this case, of course, systems like Celesto or this approach cannot help you. Okay. We've got 5 minutes left, so let's jump to conclusions. Test containers. So they can pose problems with startup speed and developer machine configuration. So they are picky about your random access memory, about CPU power, and stuff like that. Real services are black boxes, and it's difficult to force them into the desired state. Integration tests with real services are asynchronous, and asynchronous tests have insurmountable difficulties. And you must understand these difficulties. So you cannot test everything when you test asynchronously. Mocks. Specialized mocks, they are easier to connect, start, and execute faster. They don't require Docker on your machine. They just fast. They have special functionality that facilitates testing because mocks are libraries designed and developed specifically for testing. Unlike real systems, they are designed for using, not for testing them. And mocks, they never behave like the way the real system does. So this fact needs to be understood and accepted. The worst scenario for your system, specialized mock simply may not exist. The general conclusions. When you form a testing strategy, when you decide like which database are you going to use, think how you're going to test it. And let's rely not on stereotypes, but on like deep understanding. The testability of the system as a whole should be one of the criteria when choosing technologies. You should definitely, it's supposed to be a fight, mocks versus test containers. But to my belief, you should use both, of course, and mocks and test containers, they are your best friends, but your real best friends is your own head and your deep understanding of the underlying technologies. Thank you very much for listening. I'd be happy to answer your question.